Okay, so it should be recording. All right, here it is. This is the bulkhead we have to make. We can get started on that. It'll be a challenge, but we can get it done. So yeah, we decreased this material right here. This was really long, and it's just not worth it for us to have that. Uh-oh, there goes Fusion. All right, so we have it done in design. We're just gonna be in our CAM section here. We're gonna look over at our operations, and we're just gonna make a setup to start with, and then we'll begin with everything else. So it's called a job in HSM Works. And so it's gonna be milling. The model is this model here. I want the whole body. Okay, I guess fillet one. It's gonna be cylindrical, and it's gonna be a relative cylinder. And stuff is a little bit weird, so we need to go ahead and change the orientation. I need to use a z-axis and a y-axis, and the first thing we're going to do is actually going to be probably, well, here, before we define it, let's for now just select a different z. Right, so this is z. And then what's x-axis? And so we'll look at that and we'll say, okay, why don't we just pick a hole as the x-axis? It doesn't matter. Origin is going to be stock box point in top center. And so cylindrical. Okay, that's not right. We'll fix it in a bit. But for now, let's figure out what our order of operations are going to be. So for us, it's all going to be about stability. We want to figure out the best way to make this and do so without damaging anything else. And so what it looks like is we're going to want to do the top side here first, get all these ports cut, get all these holes drilled, and then flip it over and then do this in a 3-axis mill. And that's kind of the idea. Does that make sense?
Yep.
Cool. And I'll just keep going, and so it'll be a CAM thing. So I'll look at the job again. We'll fix this because it's really messed up. I don't know why it thinks it's doing what it's doing, but we'll edit it regardless. So
you're setting up the stock material, right?
yeah, exactly. I don't need to load a model. I want this whole part. Oh, hang on one second. What? No way. Yeah, no, that's not a part. Good. Okay. I don't know why when I go to the tree here, it gives me, it shows it as an assembly. So that's kind of weird, but it has the part in here, cylindrical coordinates. There's no previous job, which is fine. So z-axis actually needs to be, we're going to make it that face. And x-axis needs to be, like, it doesn't matter really, it just needs to be anything here. So for some reason, I'm confused by this, and there we go. Ah, wonderful. Okay, so we're going to go ahead and take a front side stock offset of 0.05. That's how much you want to face off to start with. And then say there's an extra 1 inch of material on the back side. And for some reason, it has it reversed, right? So we'll just make this 1. I'm not a huge SolidWorks CAM guy or fan, sorry, HSM Works guy. I like Fusion just because it's simpler, but we can make it work, right? So we're just defining it, and now this makes sense. And I have this to hold it by, I have this to machine, and I have that little bit of material. And we can update this later, but right now, this is all we need. And we can begin working on the CAM. So in terms of an order operations, et cetera, let's go ahead and start with our tool library. I want to make sure that we have the right tool libraries. And so I'm actually going to import from Fusion because I want to make sure we have everything we need. So these libraries here are the libraries that I will have imported from Fusion previously for everyone, but I have some more personal tool libraries that I wanted to export. So we'll go to this isn't important for you guys because I'm going to provide you with all the tools you need, but I've already started working on a Bulkheads one that has a bunch of different tools that would be important for this part already set up in a file. So I'm really just going to go ahead and export library as a .tools file. Sorry, an HSM tool library to downloads. And I called this PSP. Okay. It's exported. Now I need to import. So I need to say import library. Open in Windows Explorer. And we'll go to downloads and we'll just drag it in. So I will hand you a single tool library for this and you won't have to worry too much about it, hopefully. So we'll hit cancel. Everything seemed fine so far. And we'll go to PSP_bulkheads. And what the deal is here is these are, for some reason, orange, and I don't know what that means. Cutters should be fine. Oh, that's why. In Fusion, there's some features that are good for stuff, but also not good for certain things. Like there's features that don't exist. So like I'm just going to go ahead and delete that for this PSP bulkheads one because that wouldn't be a feature in this here. So if I go here and I export it and I go to documents and I go to downloads and I say HSM libraries and I say PSP_bulkheads. And then I go back to where it is and I go get a new one. PSP_bulkheads. There it is. So opening my tool library once more. Hopefully that appears. And those are orange because why? Let me look. First, let's get rid of these numbers that I don't need. I mean, okay. And they already have numbers and that's whatever. So let's start with our 2-inch face mill. So these are already here. To a library. One more time. I'm trying to figure out really quickly. Zero. Okay. Now we have all our tools in here and it doesn't matter. So let's go ahead and look at the job and start with a facing 2D milling operation. So now we have the automatically selected surface. We'll go to our bulkhead tools and we're going to grab the face mill. The feeds and speeds should already be correct. Now for my clearance height, it needs to be a 1/2 inch from the stock top. And then it automatically selects the other heights. This here is going to be my step over tool of the tool. So it's 4/3 because it's 2/3 of the tool diameter, which is 1 inch. No need for pass extension. Now step down. It's one step of 0.05, so we should be completely fine. And when I hit OK, it generates that facing operation. That does not need to be there. I created 2 accidentally. Oh, what? Okay. Correction, it for some reason created 2, and now it should be okay. It's okay. And like I can do this as a, there we go. Actually, what I'm going to do it is it's going to be from, here's a good trick. It's going to be from retract height, 0. 0.5, make default, and now that's always going to be where we want it. Is this making sense so far?
Yeah. You're
Cool.
just like positioning the drill.
What I'm doing is setting the safety planes for it to move. And so
Oh.
it needs to move up to those levels before it moves. Otherwise, it'll collide with stuff. And so I'm saying there's a safe height for you to move to, and then you got to go to that height. I've just defined the step over, and now it's generated the toolpath, which is fine. So when I go to stock simulation, I assume this is the right one. It's going to go in and it's going to face the whole thing off, and it's going to remove everything like we want. Next is roughing. There's some thinking that I have to do as we go, and that's going to involve stuff like, okay, where am I going to be for holes, etc. Drilling on a curved surface is never the best. Drilling on a flat surface is better. And so what I'm actually going to end up doing is I'm going to make a facing operation that's just going to go for a area that I need to face off. And so I'll explain that in a second. I'm not going to rough the inside because exiting on a curve is also bad. So my order of operations to start with is going to be these outside holes here. I'm going to go ahead and face them and drill them, but I'm not going to tap them yet. Does that make sense? And so let's go ahead and start with some 5-axis facing operations. I'm going to take my facing operation. I'm going to go to my library, and I'm going to go to my bulkhead here, and I'm actually going to use my Maximate 3 ball. That is not the right one. My 1/2 inch end mill for aluminum, and I'm going to select that. Now it's time to select tool orientation. We're going to start on a different axis. So we're going to use a different Z-axis. We're going to start on the double holes here. That is our Z-axis, and you'll see now that it's pointing in this direction with Z. Come on. Yeah. And we want our Y-axis and our X-axis to be something different. And so what's the deal with that is, so I think blue is that. Y, we want to be facing backwards because we want to be able to see it. So it's going to be oriented in the machine like this, and then it's going to come on and face. So here's what we can do now. I can say these are okay. I need to say bottom needs to be selection. And it needs to be 0.01, 0.1. Let's see how this looks. Right, it's up there, and that should be perfect. So now I need to select a stock contour that I want to actually face. And that's going to be right there. What is it doing? It's really just facing those surfaces. So if I were to simulate it, what it's going to do, well, stock needs to be fixed. I don't know what the, well, for some reason, it's like having a stock seizure. Let's see if I can figure it out. we'll do a stock simulation, I guess. There we go. Okay. Right. And so it did this, but that's a concern is that it didn't get all of it. And so let's see really quick. That should be fine. We'll take a look later, but I think we're okay. So I just created a flat surface. Cool. That's all I need to do. I'm going to repeat this for the entirety of it. So it's going to call a pattern. The pattern is going to be in this direction. Come on. It's going to be a circular pattern. On that face, we have 1, 2, 3, 4, 5, 6 holes. So we're going to make it 6. Equal spacing and keeping the original. And now this automatically cycles this completely around. So we've made ourselves some flat surfaces to drill on. We may have to modify this later, but now we're going to use the drill tool. And we can actually pattern this all the way around. Okay. We're going to grab our tool library. And looking at these holes, these should be 1/4 20. 95% sure they're 1/4 20. And so we want our 1/4 20 drill. We want to select the holes. That hole right there. We want to actually drill the tip through a little bit more. And so when I go to my heights, I'm going to say drill through the top, bottom. It should be far enough to clear. So there's the edge of the drill. There's the tip of the drill. Our stock top height should be 0.5 from stock top, and from retruck height should be 0 for drilling operations. I'm going to say make default, and then drilling a rapid out. And so these are our feeds and speeds, and they're correct. And now it's going to actually do all of this for us. However, when we do it, what it looks like it's going to do is it's going to switch. So it's going to do some weird, it's going to face, and then it's going to face, and then drill. And it's going to have to tool change for each one. So I'm just going to duplicate it. And I'm actually just going to get rid of this here. I want to get rid of the facing there. So now what it's going to do is it's going to face everything, drill everything, and we have an extra 1/4 20 hole for clocking. So we can go ahead and duplicate this. And all I'm going to do is select a different hole. Everything else should remain the same. So now all of this should be okay. I believe the drill should have automatically changed the tool orientation. Yeah. So that's okay. And we've got those holes done. That was the hard part. We're going to tap at the end, so we're not going to worry about that yet. Now we can feel free to rough out the entire thing. I'm going to use 3D adaptive clearing, and my best friend today, the Core 5. Tool orientation doesn't need to be a thing anymore. We want it to be regular. There is no machining boundary. Everything's fair game. The feeds and speeds should be correct. This is not a finishing operation. We want to do previous operations, so it's going to ignore the top material and those side little bits that have already been cut. 0.5, sorry, 0.5, 0. Now, I need to think about my step over and step down. 7% step over, 90% step down. What does this mean? Okay. Our stock to leave is completely fine. No worries whatsoever. I like that. But other stuff is a concern. We need to deal with the fact that the step over is 0.2 inches, which is too high. That's optimal load. So it needs to be 0.5 times 0.07. This is the ideal amount of load the tool is taking. What is this? The minimum cutting radius, 0.01 is fine. Actually, 0.02 is fine. The roughing step down that I can go is 90% of the tool length, the flute length, 0.9 times flute. And so we'll make it an edit expression actually. So if I go to edit expression, 0.9 times tool underscore flute length. If this takes, we're good. If it doesn't, it doesn't. Okay, 0.9. And then the tool length is what? So we'll look at this here, and we'll see that it's a flute length of what? And so we'll just edit the tool. 1.5 inches. So 0.9 times 1.5. And that's a fine one. Minimum axle engagement, that's fine. Flat area detection is good. That should be 0 is fine. Boom, order by area. Now what's going to happen? Generate it. What is it doing, you may be asking? It is roughing, so it's going as high as it can. It's going to take a sec to generate. It's a pretty intensive toolpath. Let me check my... Okay, it looks pretty spicy, but it's just roughing. There's some concerns I want to keep an eye out. I want to make sure it's not going inside and other stuff, which it's not. We're all set there. Now, I'm actually going to do something that I didn't think of that I want to fix. I want to change my my stock to leave to be more reasonable. Okay, so we'll let it regenerate. It shouldn't take too long because it's just a small change. Our operation has now done its thing. My tool feeds super fast, so it's exciting to rough with it. Some concerns we have now are the length of the tool, though, so we'll have to keep that in mind, right? And so our end mill is extremely short compared to this outer length here that I'm staring at. So we may just want to rough the inside in a single operation. And so we're going to edit it, and we're going to set a boundary for this machining. We don't want to deal with the outside. We just want to deal with this. So let's see what happens when this happens. My flute length is 1.5 inches, and my length below holder should be about 2. So if I were to go to evaluate and measure, and I were to go from like down there to there. Oh, you gotta be joking. Okay. Measure. Measure. Once again, we're going to try one more time because I'm bad at selecting edges. Okay, please be 6 inches is not the right answer. Okay, 0.42 inches. So it's about half an inch? No way. Let's see. 0.7. It's probably 1.42, isn't it? One more time. Ignore my bad skills there. 1.42, wonderful. So that's the length my tool can go. That makes sense. This I'm going to have to do something special for. Not the most ideal, but we're going to have to use a steel ram or an extended inch and mill. Ideally, just a steel ram, and I'll explain in a second, just because of the length of this part. So we'll do the inside first, and then we'll deal with the outside. It's always best to leave extra material on the outside for rigidity. So now this is going to rough everything out here, and that solves our problem. Next, let's think about one thing at a time. What the heck is this guy here, right? And so we're going to measure it. And it's a 1/2 inch hole. So let's just go ahead and rough this out and then drill it. So we'll grab actually we're gonna drill first once I figure out the length of that. Is that too long for me to get? I should be okay. So cam, drilling, drill. That's the hole. I want a 1/2 inch drill in my PSP bulkheads library. This should be a carbide. That's a 3 times diameter drill. We may have to grab our friend the 5 times diameter drill. Let's find out. Although, actually, I think we're going to be genuinely fine. That's our face.
What does the number mean in that 3 and the 5?
Cool. So that's the ratio between the length of the drill and the diameter of the drill. 5 times D would be 5 times the diameter. So 2.5 inches. 3 times D is 1.5 inches in long. So that's just the meaning of that. And let's get our breakthrough depth of 0.2. I want to make sure
Gotcha.
like we really clear this edge. Actually 0.1. And so that's like genuinely going to do it. But now here's the concern, right? What is this length? If this length is something huge, which it probably is, right? I'm going to have to grab a different drill. So if I were to, we're going to put you right there. If I were to simulate this tool, what's going to happen? We'll go a little faster. Goes through. Like it broke through there and it's actually going to be okay. I think. Yeah, no collisions. So that means we're okay. So the distance is fine. So that's our drilling operation. Now let's deal with this guy here. What is this, right? Well, let's look at the radius. We need to figure out what tool we can use. We'll measure the radius and we'll see that it's 0.25. So I can take a 1/2 inch tool here to get these corners and do it all. So that's a good thing we can do. It'll be pretty quick that way. Or we can take a 1/4 inch tool. Let's use a 1/4 inch tool, right? And so we're going to grab my friend, the 2D adaptive, and then we're going to hit it with a contour because we need to rough out all this material. So I'm going to take my PSP bulkheads 1/4 inch end mill. Speeds and feeds are fine. Model, what am I doing? Oop, got to delete this because I messed it up. We're going to grab that. It automatically selects the contour there. Well, I want to make sure I'm on the right position, right? I want to make sure I'm getting the inside. So I need to reverse it. No, actually, I think I'm okay. It doesn't need rest machining because I'm selection based. And the bottom's fine. 0 offset, but 0.01 is fine. So if I were to say 0.25 times 0.07, 0.0175, and so 0.01 is a decent depth of cut. So once again, like this is my step over. This needs to be 0.25 times 0.07. Remember, kids, 7% step over. No, I'm kidding. It's good. And so multiple depths, 90% of the flute length. What's my flute length? It's a 1/2 inch flute length. So 0.5 times, but I think we're going to already be fine, right? So 0.5 times 0.9. And we don't leave any axial stock. And so those of you that were present for any of the machining we've done, you'll remember the finish on the adaptive versus on the contour. Adaptive will leave little facets on curved surfaces. That just simply means that it's the fastest way for it to machine. And it keeps putting it in there. But this is not going to leave straight edges on these points. See how these are faceted? It's faster for the machine this way. However, we finish it by creating a derived operation and contouring. And a contour is what gives us our good surface finish. We'll drop the feed rate in half to 0.001 feet per tooth. And then that should be fine. So now, go in the right place, please. It's on the wrong side. See those lines? It's actually going to cut in the wrong place. So I got to fix its selection set and just simply hit reverse. And there the arrow's inside. It means it's going to cut on the right position. Anyone have any questions so far? We're going to actually turn on, I think we can turn on rest machining from the previous operation. No, we'll be fine. It doesn't matter. It just won't cut anything for the first few cuts, and that's fine because we already drilled. That's our pair, remember, adaptive with a contour. And that's done. Now what's the next stuff we got to do? We got to deal with these ports here and their holes. And we've got to deal with all of this surface finishing. Let's do the surface finishing last because that's one of the least important things. Let's start with each of these ports. So we've got I'm about to ask a lot of silly questions, but let's see. This is a 0.46. So this is our 1/2 inch port. This is our 3/4 inch port. Okay. We have our 3/4 inch port cutter, right, Bruce?
Yes, we do.
Perfect. So because of the fact that this is a 3/4 inch port cutter, I don't have a 3/4 inch drill. That's completely fine. This is modeled correctly, so I'm going to use an end mill to adaptive this out and then rough it and then finish it. And so I could take a 1/2 inch end mill, go down in here, and then finish it. But first, we're going to face off these portions because I already had some stock to leave. And so I want to face them to make them nice. So I'm going to go to my features. I'm going to go ahead and I'm going to go to CAM. I'm going to take a facing operation. And I'm going to use an end mill to face. We're just going to use our 1/2 inch end mill. Feeds and speeds are fine. I am going to select my stock contours because I want to make sure that that is right there. And my heights should be from selection. Contour. Those are all good. Step over. Remember, it should be 7%. So 0.5 times 0.07. No need for multiple depths. That actually takes a long time and is relatively pointless. So we're going to grab a different tool. I have a 1-inch steel ram, KCN shell mills. This guy is perfect for that. See how long and extended it is. It's nice. So we're going to use this as our facing tool. Feeds and speeds are fine. It's 1 inch, so 7% of that is 0.7 inches. Multiple depths is not needed. And now, boom, that's done quickly. This guy is going to be more of a pain, right? We want to get this nice and flat. So I'm actually going to end up just selecting a adaptive operation, and I'm just kind of cheating a little bit, but we'll see what it does in a second. So 2D milling, adaptive clearing, right? And so I can also cheat here. And so we don't want to use this because of the curve. It's perfect for facing this because of its curve, but it's not great. And it's going to be used for the outside here. It's not very good for the rest of what I'm about to do. And so we're going to choose a different tool. We're going to go back to our 1/2 incher. We can use it here. I'm going to select the face there as our adaptive. And right there. And say, that's not what I want. I want the edge. There. It should be inside of it. And so what I'm going to do is say, there's my end mill. Let's give it a look and see what it does. Okay, that's unique. Let's look at why. Let's start with our edge. Good. Let's get the face as well, see what it does. And 0.5, or sorry, 0. Bottom. This blue is, I guess, the height. No stock to leave. That explains it. And, oh, actually, I'm thinking about what's the best way for me to go about this toolpath. Because what we've done is we've left material here. I want to get this to be a nice sharp corner. I want this to be a nice contoured edge. I don't want to have any problems with that, though it doesn't really matter too much. So let's think, what's the best way to do this? I'm thinking still. What's up, Will? Let's try a facing operation with that end mill again and see what happens.
How's it going, guys?
Good. We'll do a pocket, because why the heck not? And lead in and lead out, we're actually going to do
Who uses 2D pocket anymore, Jeremy?
I'm trying to face this. I don't want to leave 0 vertical stock to leave on my adaptive that I'm using to rough with, because I want to, I don't want it to, oh, actually, hang on. So I have my adaptive that does all this. I have no stock to leave. I have vertical stock to leave because I don't want to gouge the bit here. Problem is I want to hit this again later. So what I'll just do is this, edit. I'll just duplicate it. Okay. And let that run to generate.
How's everyone doing today?
Good.
Doing good so far.
Yeah. Recovery review went really well.
Good.
Those guys did a great job, so that's hype.
Let's fix this. Axial stock to leave, it does matter. Now it's as if we did the whole thing over again. And that is not what I wanted to do. So we'll just fix some things some more. Sorry. Sometimes with 5-axis and complex parts, it's really just a game
Mm-hmm.
of
Yeah.
just tweaking over and over again and seeing what happens. Okay.
It's kind of fun when people like clients come in with like tough parts and they're kind of like they don't realize that, and I'm like, give this a shot.
Yeah, this is the cringiest lead-in I've ever seen, but we're gonna see what I can do to fix it, right? And so we're gonna say, I don't want a helix, I want a plunge. Entry positions. No, do I want a plunge?
Plunges
Stop
are
it.
gold, man.
No. Well, let's look at this a little bit more.
It's kind of, I don't know if Jeremy's explaining all this stuff, but just to narrate while Jeremy talks, with an end mill, you can't do a direct cut downwards. Like you can't go straight down with the tool because the very center of the tool isn't centering. Especially with something like a shell mill, which I think Jeremy's using right here.
This is my core.
Is your core? Okay. But even so, the center of an end mill can't cut, so you can't do a thing like a drill where you just go straight down into a tool or into a workpiece. So what you do instead is you do a helical movement, and you essentially combine a sort of lateral movement with a downwards movement, and that lets you cut with the edges, and it's lets the tool be happy, but still allows you to pocket and do all that good
Right,
stuff.
this is fine. So I'm just, yeah, see, I just kind of just screwed with it until it gave me what I wanted, which is just a flat surface. So now we can deal with our friend over here. This is going to be a fun one. Let's see what happens. We're going to be drilling with an end mill here. I keep clicking around more than I need to. I guess that 2D adaptive is fine. And now it's going to generate or it's going to fail. These need to generate. I'm going to grab a drink of water while they run.
I don't know how y'all are feeling, but today is a hella cozy day. It's
I don't
kind of
have my
hard.
camera on, but I have a blanket on my
Oh
shoulders
my
and
God.
slippers on my toes.
The heat's on. It's raining outside. Oh my God. It's a good day.
These are generating and they take a while, but set. Alrighty, now we can do this and see what happens. Okay, it won't work. Why? We're trying to go into a hole that's actually too Jeremy's brain's slow today. Too small. So we're going to pre-drill and do something else. This is a 3/4 inch hole, so I need to drill ahead of time to get in there. So that's what we'll do.
Are you using a 1/2 inch?
Yes. And then I'll get a 3/8 end mill to come in and finish.
You could also decrease the helix diameter.
Yeah, because there's no helix involved, and so we want to break through by a fair amount. So we'll drill tip through bottom. 0.1. Cool. That's solved. Now it keeps putting stuff in there. I don't want it to put stuff in there. Now we're going to go ahead and do 2D adaptive clearing followed by a contour. So we're going to go to my library, KCN end mills, and grab a 3/8 inch end mill. Our heights model, you're there. We're going to pre-drill. Really? Pre-drill. Okay, so let's see if it can center itself there and not like have a seizure. Multiple depths if I need to. I shouldn't need multiple depths. 0. Bruh. What in tarnation? It should be pre-drilled. I don't get it. Let's find out.
CAM is all about trial and error.
Oh, it didn't show up with a pre-drill. That's why. Whatever the heck that was. But I assume that's right. Yeah, dead center, and then it'll go down and come back out. Perfect. So when I simulate it, what you're going to see is it's going to do this. We'll make sure that it actually has enough flute length, which I believe it does. It's going to go straight in like that. Yeet.
Nice.
And then we're going to come out and contour it. So remember, create derived operation keeps everything the same. And there's our 2D contour. Do we have a 3/4 inch tap, by the way?
Do we have one? Or does Bechtel have one?
Bechtel. We may have to thread mill this, which is going to suck.
We can always buy one.
So, well, we're not going to deal with tapping anything as of now. But,
I had a
we've
question
done
about
this.
the
Yeah.
gold stuff. Is that those are like overlaid after we do all the machining?
Oh, that gold is just a port indicator for the whatever fluid is going through it. So I believe in this case, this is the methane. Or not the methane, the helium.
Whatever to make these SAE ports, we have just like a design library thing that you kind of drag and drop on there, and by default it gives it that gold color on the part.
So this
Like
is
if you go into features, Jeremy, if you want to just show it off real fast. Oh, not the features tab. Sorry, the design tree. That guy, yeah. The MS33649. When you drag that operation in, just by default, it makes it gold.
Oh, okay. Yeah.
Oh.
That saves us the pain of modeling that surface each time because those suck. Yeah.
There's the finishing operation. Please be the finishing operation, right? Bro. Oh. Yeah, so it decides it wants to reverse it every time I do that. There we go. Done. That's the finishing operation right there. Now all that's left is going to be cutting the port, and then we'll have to tap it. And we can always tap this by hand if need be, but for now, let's just cut the port and leave it at that. We'll deal with the threads later when we have a better idea of the tooling we have available. So let's start with the, geez, what the heck is that? Okay, let's start with this port cutter. So I need to make us a port cutter in our tool library. And I'll make this tool library available to all of you guys when it's time. So we're going to make a new mill tool. It's going to be called a, what did I call it? I just did a counterboard, didn't I? Yeah. So diameter is relatively unimportant. What's the SAE? What's the tool cutter MS number? MS 16.
Oh, were you looking at the feature in SolidWorks?
Yeah, I just need to know what I did. What the port
AS5202 is what you want.
No, I know, but what's the tool that we bought? It's MS. We'll just do SCT tools. Scientific cutting tools. Let's see. Products. View tools. These are it, right? 1.6, yeah, product page. Cool, this is a 3/4 one, so it's going to show up as this. And so 1642.12s. what are the primary diameter of that? It's going to be P, which is 0.97. Excuse me? P. That's why, because we selected the wrong tool. It's this one here, 1/2-inch tube, 0.75 through 16 thread. And so it's a 0.685 diameter. I'm just making a really rough tool. It's not going to reflect the actuality of the tool. Shoulder length. The flute length is what? That's J. And the shoulder length is up until this bit there. And so it's going to be the overall length minus L. So OAL minus L is 3.57 minus 2.12. 3 point. And then the overall length is, the shaft diameter is S, which is 0.75. This really doesn't matter too much, but it's just a matter of us getting things sorted. And so the body length should be 3.57. It's a weird number, but that's that. And then the length below the holder, right? What's the length below the holder? It's going to be like, sure, like 1.6, something fun like that. Flute length, the shoulder length is 1.45. The flute length we'll call J, which is going to be 0.560. Done. Okay. Edit it once more. We're going to finish it up. We're going to call this the, has four flutes. 0. Okay. Carbide, flood coolant, 4 flutes. So this is a oh, it doesn't give me a, that's fine. So 100 RPM, not 10. Good. 4 fluted. 2 inches a minute. No, 1. Good. 200 or 100? What did he run it at?
200.
And 1 in, 2 out?
I think it was 2 inches per minute, yeah.
In or out? Both?
In. That doesn't matter, right?
True.
Let me double check that.
I mean,
It didn't seem to matter too much, like the specifics, as long as it was on
it's so
this order.
small.
Yeah.
So now we can do our drilling, right? We're going to grab our drill. So here's where you guys have to be very careful. There is no wonderful way for me to model all of the port cutter in here and make it all easy to measure and all that. So you got to be very careful about what our depths are set to. Otherwise, you'll have an issue like I had when I messed things up. So we're going to grab our MS tool from, is it in here or did I put it over here? I put it in here already for us. It's our counter bore. So select. I'll fix the name here. Edit.
Looks like we might have done 150 RPM.
Yeah, it doesn't matter too much, but let's edit it and see general description.
I'll just double check that so we can.
It's like super easy to do, so that should be okay. MS8S, good. So now feeds and speeds should be set. Heights are important. Let's figure this out now. Let's do it. So we got our hole. Bueno. Heights, bottom. This is what gets spicy. So selection. This is our top height. We want to go down the depth up to the edge of this chamfer. So let me explain. The measured 0 of our tool is from this flat face. And we want to go down until this barely doesn't touch the surface of it. So that's the J value, is our depth from the face. So J on the 8S cutter right here is 0.560. So I go minus 0.560 from selection to make my whole bottom. And that's how I set up the port cutter. So this is one you'll have to be extremely careful with. Why? Because if it goes wrong, things will break. So let's go back up to edit, and we're going to make sure our top height is set to something reasonable. And we don't want 0 from the top. We want it to actually be it from the top. I selected this inner hole thing to align it to the center, but the hole actually goes deeper, and there's already material that's it's missing. So we're just going to actually make it from selection. That's our selection for our top. And now you can see that the green goes all the way up to the very top. And so that's the start. That's the finish down there. When we simulate it, it won't reflect accurately what we're trying to do, but that's fine. All we got left, guys, is one more hole. So let's think about what we want to do first. Let's deal with this small guy here. What is that? That's a 1/2 inch or not? Let's see, measure, evaluate. What the heck is 0.23, Will?
0.23?
Is that supposed to be 0.2375?
I was not paying any attention at all.
My question is, what is this tiny hole here?
Oh. I think that's the default for the thing. It doesn't matter too much.
0.234?
It really doesn't matter.
Wait, what is this? What's coming in here?
It's a port.
You don't know what's flowing in.
Oh, it's a PT, I think.
Okay, so if it can be a 1/4 inch hole.
Yeah.
Okay, good. So
Yeah.
fun fact, kids, no matter what it says in, and I say kids because I'm memeing being okay, you know what? We're not going to do that again. I'm sorry, kids. It's Saturday morning. 1/4 inch drill. Okay, 1/4 inch drill, 5 times diameter because we need a long one. Select. Now I'm going to grab this hole here. What I was meaning was that for the drilling, you can select any hole and select any diameter tool. They don't have to match the diameter of the part in the model. So we're going to make a selection for our top. This is where it's going to start drilling. We're going to drill through the bottom, 0.05. We want to make sure we kind of get that nice and good. So that's a PT. There's that. There's our tool feeds and speeds. The heights are fine. That's a drill. Wrap it out. Let's make sure that it doesn't die when it tries to run, because if our length is too long, we'll run into an issue. Okay, let's see if we crash. Nah, it's okay, good. Yay. So that worked. Now we got to get the inside here. It's going to be difficult because we have to use a high-speed steel drill. This is a 1/2 inch, right? So we got to use our number something. What was the pre-drill size? What was the diameter of the tool we used for the other tool?
I'm not sure.
We're going to do this after something else. Let's see.
Have you explained what how like tap drilling works?
How tapping works?
How tap drilling? Yeah, tapping and tap drilling, I guess.
Yeah, so you pre-drill larger than the minor diameter of the tap, that way that it can, or you pre-drill smaller than the major diameter of the tap or the minor diameter of the tap. So when the tap comes in, it actually pushes the material around to form the threads because it needs to have material to work with. So if my major diameter of my tap is 1/2 inch, my minor diameter might be like 0.49 or something silly like that. And then I just pick a drill that's smaller than that, and there's preset drill tap charts.
That's only true on thread forming, right? Most of our taps are cutting.
Same deal. I mean, sorry, not forming,
Yeah.
but it's cutting material out.
Yeah.
So regardless, it has an associated diameter or a tool that you select. And so, so for a 1/4, so we're done when we chose a fine thread. So 1/2 needs a 2964 drill. So we have a fraction drill at Bechtel that's a 2964. So I'm going to make that tool in our library for it, and then we'll name it something special. So we'll make a new mill tool, make it a 0, high-speed steel, flooded. We'll make this MS, so we'll make this 1/2 inch port cutting drill, port drill. So it's going to be 29 divided by 64. Flute length, all that doesn't matter. It's a drill, not a mill. Good. All this is fine. The length is absurd, so we're going to make it 2 inches long. Okay. This is unimportant, but 1000 RPM. Let me pull up the drill chart I have on my phone, and I'll explain that the drill chart still gives us a diameter for point. So 29 64ths is almost a ½ inch. So about a ½ inch drill gives us a RPM of, for aluminum, of 500 RPM. 500 RPM. 2 flutes is what it is. It's made of high-speed steel. Good. Feed rates. For a ½ inch drill, inches per revolution should be about 0.007. So 0.007 is our feed per revolution. Clockwise is good. There's no ramping. That doesn't matter. So that should be correct. So there's our ½ inch port drill. We won't tap yet. We'll deal with tapping later. In fact, it may just be easier to tap by hand on the final part. I don't know what Will thinks.
What is that?
Oh, it might be easier to tap by hand on the final part, but we'll leave the tapping till later. I'll do all the tapping for all the parts in another deal for that. But
It's not too many threads, but
no, 2964 drill. Good.
it would also suck to scrap a part because someone fucked up a hand tap.
True. Okay, so we'll drill tip through bottom. Cool. Now it goes all the way down. Concern: long drilled cycle requires peck drilling. So we're just going to go ahead and just, even though this is short, we're going to peck drill anyways, and it's just going to do what it's going to do. So we'll do a peck drilling. Chip drill.
Vishal and Bruce, you guys know what peck drilling is?
No, I do not.
Nice.
So it actually bounces up and down inside the hole to break the chips and get rid of them. And so when I put this in the right spot, if I simulate it, I don't know if it does that for this. Let's see if it actually shows you what that does. So when it gets in there, it's going to go down. And I don't think it modeled the peck drilling, but it moves up and down repeatedly inside the hole. And the peck may be too small for it to matter in this case, but it moves up and down inside of the hole like once or twice at a certain specified distance to let chips evacuate from the hole and make sure it lets them clear. Is that right?
Yeah.
Good. Okay. So let me fix my heights.
Hey, Jeremy, I gotta get some food before this cat jam thing.
Yeah, no worries. We'll be done with the cam jam soon. So
cam jam, that's tight.
Let's make the port cutter we need to make for our tool library. It's the same deal here. So we're going to grab our MS8 or 8S port cutter. So we've got our counter bore here. We're just gonna duplicate it.
Jeremy, I've also been thinking a little bit about tube manufacturing.
Yes.
So if you want to hop in the CAD jam, we can just talk about that.
Okay. Let me get our dimensions for this port here. It's yeah, we'll do that then.
See you guys.
Half 20. Its diameter is P, which is 0.448. The shoulder length and diameter should be 0.5. That should be there. Flute length is what? That is the length below the holder that we need to get J. That's 0.465. And body length, all that doesn't matter too much. Feeds and speeds are the same. And it's going to be a 5S. Whee! Okay. Let's see if it's a 5S or a 4S. Yeah, it's a 5S. So that should be fine. Okay. So now I can create my drilling operation like before. Same exact deal, different cutter. So we're going to grab our 0.448 counter bore. Speeds and feeds are fine. We're going to grab this hole here. Now we're going to do our magic with our drills and our selections. So selection, our flute length was 0.465. So we can go 0.465 down. Selection from the top is where we start. So now that's that. So if I simulate the entire thing, Okay, so there's that, there's that, there's that. Let's run the whole thing. Oh gosh, yeah. Some reason it always has trouble with that operation. We don't need that anymore. Any questions while I'm going? Oh, cool. Okay. This whole thing should be simulated now. What happens if the stock should be fine? Let's see if the stock works out. So for some reason, okay, I guess that's what it's going to be. It's going to have the stock be the wrong stock, but I guess it's fine. The inside is what we care about right now. See that? It's going down to its depth. It's helicling, and now it's going to do all the roughing. And so you can see it roughing. This is a lot of material it's taken out. It's working its way up. It's leaving little edges there. It's going to face that out. All those get done. So now if I hide the toolpath, there's our ports that are cut. There's the little bit there. It's just not the best looking simulation, right? But then there's those. See these little islands that has to get finished out later. All that should be good. And now it's like, that's good. So the outside's an issue, but we won't deal with that for now. We'll do that later. And so we'll have to do the backside at another point, but let's finish this entire top side in this first operation, and then I'll come in and do the next one at another day, maybe tomorrow sometime, or this coming week, since we're not doing this till after break. And so this is done. Ports are cut. We've got to finish this inside. We got to do the outside, and then we got to deal with the rest. And so let's go ahead and start with the outside, and then let's do the inside, and then we can do the finishing operation. So the concerns I have, right, are like this right here. What's the deal? It's too small of a diameter. Let's measure it. It's 0.25. We need this to be a nice, let me think. We can do better. We can do better. This is going to take a sec, right? But we're going to leave very little stock to leave. I want to better get into this corner because it's kind of full of material. And by proxy, fine, okay. I'm changing the stock to leave so that I can get further into this corner, because if I leave 0.02 inches of stock, it can't radius this very well. And I just don't want to overload my tool when I do a quote finishing operation on it. So while that's running, we're going to go a 2D contour for this inside portion. And we want to flip that arrow. So I'm just getting it to go in there. Yeah, good. Okay. Reverse. Now it's inside. and I can select an edge. Okay. Need to get that better. Okay. So now we'll use my really long end mill, which will be able to do this. The tiny guy can't do it, so we'll use my big guy, my core. And we'll let that finish it. For finishing, we divide this by 2. And we divide this by 2. Divide that by 2. And you don't matter. That's all good. And it's on the wrong side, so we got to fix that. There we go. Let's see what happens. So this should create a nice lead in and lead out. For some reason, all of these don't like to generate, so we're just going to do the whole thing all over again. Let's let it run, and this should be giving us a good bit of stuff that's already good. Okay. Next, it's going to be a morphed spiral that we use to do this part, and I'll explain that in a little bit when it's done making everything up. How are we doing? It looks like it made it through. So that should be a wonderful contour. And it's not, so let's find out why. There's my core. There's all the edges that it needs to hit. That's going to pose itself a problem, so let's fix it. Why is it going to pose itself a problem? Because the tool is going to exit in a very weird way, and that's not good. So let's figure it out. And bump, 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 and reverse it. It needs to be on the right side there, so reverse. And done. Okay. Come on, generate. Let's see. Oh, okay. Good. So hopefully it won't gouge when it exits, but I have an unfortunate feeling that it will. So we're going to go ahead and edit the exit and entrance conditions, right? We don't want it to hit anything over there, but the edge likely will. So how do we do that? We change its lead ins and lead outs. So we want to actually exit at an angle of 45 degrees. Oh, we'll make it 120. There we go. We really wanted to kind of double back and not gouge. Let's see if that works or if I gouge. So what happens when I simulate? Go. Okay, yeah, that's a problem right there. See that? That's what I was worried about. So what do? We got to fix it. And so we'll go ahead and make it 180 degrees and it'll be different. Okay, that's going to be our lead out. And so hopefully that won't gouge. And if so, we'll have to change some more stuff, but oh, it still does. So does it much? See, that's really close. Actually, we may want to change the lead out to be a different kind of lead in and lead out. See, this is where the tweaking comes into play. You got to really just mess with it. And so, done. Oh, no. That's that. That's that. Okay. Hopefully this works. Let's see. Come on. What's the deal with this? Right. So the exit is different than the entrance. I don't like that. We got to figure out why. What's we got to fix? So. See, this is just a game at this point, and it's really somewhat obnoxious, but right there. Generate, and it fails. Why? Those can't be there, I guess. Okay, now we can tangential. Okay, there we go. That should do it. Good, perfect. I just tangentially extended a different amount, so it shouldn't have that issue. But it's gonna still be weird, so we need to fix that. We're just gonna make 2 of them. Okay, let's see if it actually can do it without being obnoxious. That's gonna plunge, and that's not good. That's really bad. Okay, we'll delete. We'll come back to this. It's just gonna be the way it is. Okay. Instead, we're gonna simply okay, ignore this. We're gonna do the 3D surfacing, and then we'll be done for the day. 3D morphed spiral. What does that do? It goes around stuff that's in the way a little bit better. We're gonna grab our KCN end mill. Sorry, our Kyocera end mill, ball mill. Come on, Kyocera. Where did I put it? Okay, PSP bulkheads, KCN. Okay, select. This is our ball mill. Speeds and feeds are fine. They're slow. We can up them later. Now we're going to say machining boundary selection. This is our selection. It needs to stay inside of it. So we also want to select that as our selection boundary. That's fine. Contact point boundary. What is this about to do? We'll find out. So this needs to be let's look at this. What's it about to do? So it should It's generating. Come on. The adaptive's generating, and we'll come back to this one. Okay. So this is going to be the difficult stuff, is these spirals, and I'm happy to be the one to help with these, but let's look at this really quick. What does this say? Safe distance, that's fine. That's fine. Lead-ins and transitions are okay. More spirals, fine. That's okay. Like we have our machining point boundaries, and that's fine. But we need to probably want to do touch and avoid surfaces. So let's go ahead and make some touch surfaces and see what it does. Maybe it doesn't need those. Let's look. I'm really not touch check surfaces. This is what this is doing. It's going to say touch these surfaces. This is what I want to machine with it. That's all of it. Let's give it a generate and see what happens. And let's actually change the step over to be a little bit more. Like surface finish on this is not the most important thing in the world, so we're just going to slow it down for a second. So hopefully it doesn't take as long to do its thing. There we go. Okay. What is this doing? This is actually generating all the toolpaths. And so when I simulate it, let's see what it does. It's just going to start its morphed spiral. And it's going to start doing its thing. It's going to start making its way around. And it's morphed in it, so it's kind of whack, but let's see if it can actually do it without messing up. Okay, there we go. This actually will be better as a regular spiral, so we're just going to suppress this for now, create derived operation of a 3D milling spiral. We'll just see what this does when it runs. Much better, much better. Delete. So what the morph spiral does, just so you guys see the difference, is it morphs the entire spiral around these edge features. But that means that it's kind of a nasty start. And this is a perfectly round piece, if that makes sense. Whereas the spiral just ends itself here. It realizes that it's going to reach its end, and so it doesn't go there. So if I go ahead and delete this morph spiral, we have what we want here. And so when I simulate it, it's going to just spiral itself through. It's going to start here in contact with everything. And then it's just going to make its way all the way around. So that's a lot of movement to get that final bit, but that's good enough for now. Let's simulate it and see what happens, right? And we can add more finishing operations later, but let's just do a whole entire stock simulation. It keeps invalidating some of these operations. Let's skip to the end of everything and see what it does. Oh, our tool extension's a problem we'll have to fix, right? It's realizing that now, but look at that. See that? That's what it's doing. And see, it missed a little bit that we want to get later. Okay. That's an insane amount of change we're gonna have to make to this tool, but hopefully it can keep up with it. Okay, so looking at this right here, let's look at our tool and see what's wrong. Okie dokie. Here's our Kyocera and ball mill. KYCN, edit. Cutter, length below holder. Here's our problem. So it's a 3-inch overall length. That's 1.35. We're going to make it 1.75. That's extended. The flutes are bad. So, okay, yeah. Good. Problem we realize now is that our flute length is 1.35, but the whole length is too high, so we need to finish this without it. And so we're just going to add a contour. Ah, that's not what I want. So we'll go here, right? We'll go here, and that's perfect. But the problem is like, okay, what's the deal with all this stuff here? So we're actually going to change our height. We're going to make it from selection, bottom. And we're going to use our 1/2 inch KCN end mill. Perfect. What am I doing? I'm getting this edge so that when I run my ball milling operation, it doesn't scrape. This failed. Let's find out why. Because I selected a face and not an edge. Solved it. Done. There we go. Now we know that our cutting flute won't be rubbing, or the rest of it won't be rubbing as much. And so that's exactly what we wanted. It's going to take some absurdly high load right here, which is stupid, but let's see if it does that. Let's look at the adaptive that we have. So unfortunately, we have this issue where adaptives continue to not want to generate correctly. But let's regenerate them. So this is almost done. This is done. So we're good. Now we've done the inside. We got our contour. We got our spiral for now that will change later, of course, as we get things better. So, well, let me think about like, what's the last issue that I want to deal with? And I want to deal with this nice edge here. And so I want to get a nice contour on it for stuff that was missed. So if I select a 2D milling contour, 3D milling, sorry. We want a flow from this Kyocera along this. So this is what I want, right? What am I asking it to do? I'm asking it just to take the tip of the tool, put it along the center, and go. Let's see if it'll generate. Perfect. So now all that's left is for me to get this really nice looking little edge here, doing my best along it. I can do it in one pass. I don't need multiple passes. One pass, that should be fine. So in case you guys were wondering what I just did, this is an operation that follows this contour and tries to get the radius for me. And so I think everything, if I were to simulate this whole thing, Every time, man, every time it just redoes this because it accidentally, what it does is it accidentally put the flow in front of these tool paths, and when it automatically adds that tool path, it needs to regenerate these. And so what happens is when I move it around later, it all requires regeneration. So now that should be good, we can get all of this done. And so I'm just going to make a 2D milling adaptive, right? And so what am I doing? I'm gonna deal with our friend the shell mill. So I want this right there. I want my 1-inch steel ram because I have no tool that's long enough otherwise. And so here's my 1-inch steel ram. Where are you? There we are. Select. Feeds and speeds are fine. Edge is fine. 0 stock to leave. 0. What we want 0.1. 0.01 stock to leave. Fine. 2. 0 axial. Good. That's fine. Now, multiple depths and step over. What's the step over I can do with this? We're pretending it's an end mill, so we're going to do 0.07 times 1. Multiple depths. What is my tool's flute length? Library. Let's take a look. Flute length is 0.62. 0.9 times 0.62 is my. So that should be fine. Okay. And I'm gonna have to regenerate everything again because it sucks, but edit, we realize we're in the wrong direction. It needs to reverse. Come on. There we go. See what it does. Nope, it's wrong once again. Good. Machine cavities, that was my problem. Haha. Now it should be this. Good, okay. And that's gonna do that for me. It's gonna leave a radius there that I have to deal with later, which we'll have to, it'll be unfortunate, but it'll be the way we'll have to deal with it. And so we will. Let's leave that and create a derived finishing operation without stock to leave. It's just going to do the same thing again. We're going to drop the step down because of those edges that are going to be a problem. Right, so we're using a rather tall tool. So unfortunately, we're just going to make it step down 0.5. Let's see if that fixes it, because there is a corner radius. Now we've got some issues with this corner last year. This is going to be really spicy, so let's see what happens. I'm going to create a multi-axis contour. Tool, select, good, contour. See if it can do it. The problem being the tool we used is a shell mill, has a radius on it, so we can't have a radius slotting in. So let's look at our tool orientation. There's z-axis, and we want to reverse our y-axis. So now it's still having issues generating, so let's find out why. We'll try another 5-axis operation. This is unfortunately not a great deal, but it'll be what it'll be. We just don't have a tool with correction. Evaluate. Let's find out if we have a tool that actually might be able to do this for us. 2 inches. Do I have a 2-inch flute length tool? Let's find out. CAM. Tool library. KCN extended end mills. 1/2 inch. What is our flute length? Sorry. Shoulder length is 2 inches. Perfect. Okay. This is exactly what we were looking for. Edit. We're going to replace this with the right tool. It's going to be a painfully large amount of time to finish, but it's going to do its thing. So library, KCN extended, 1/2 inch. Okay. Step downs and step overs need to be changed. So it's got a 5/8 inch flute length. So step down has to be 90% of 5/8. 0.9 times 5/8. Okay. Perfect. Delete that. And this solves all of our problems. Create derived operation. 2D. Anyone have any questions about what I'm doing? It's kind of jank, but
Yeah, good so far.
okay. Yeah, adaptive contour. Super long tool with tiny flute length. That's the flute length right there. So it's just going to take multiple passes, but it has a 90-degree angle at the tip. So I don't have to do anything silly for this. And so that's done. That's everything. This is a really first draft. So when I go to stock simulation, okay, generate again. So that's rough. But now when I go to stock simulation and let it run, this should be everything that we need. Without taps. And we'll add the taps to the library later.
So I'm not quite clear on what taps are. Like they're for the holes.
Yeah, let me just show you a picture. You'll understand more.
Okay.
Finally, there we go. These are taps. Right, and that's actually a combination. We don't want to do that. We want just a. Okay, this is a tap right there. So all it does is cut the threads. So you have to drill, and then you cut the threads afterwards. It doesn't actually drill along the way.
Yeah, it's pretty clear what it does.
Cool. But now you just got to be aware that when you tap, the feed rate and the spindle speed have to match so that the angles of the threads stay within each other. Because you cut a thread, then you stay inside the thread you already cut as you go.
Mm-hmm.
And if they aren't synced or they switch a little bit or it doesn't reverse perfectly inside the hole, it'll break. So it actually stops and reverses, keeping itself inside of these holes here.
Mm.
That's what's difficult about tapping.
Gotcha.
now that this is done, we'll do a stock simulation and let it run. Okay. Who just gave me the seizure? Let's find out. Flow clash with stock for feed movement. One, two, three, four. Ba 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 ba. Okay, tool fruit for operation. That's fine. We're just going to pretend that that's not happening, and we're going to call it a day because we've got most of it done. I'm going to spend more time refining this later. For all of you guys who are doing CAM for these parts, all I want is a rough attempt. So if you do an adaptive and the tool holder's colliding, don't worry. If you do an adaptive and you forgot to get the flow later, you don't know how to finish this nicely, don't worry, because I'll come do it for you afterwards and refine it before we machine. But like if you guys get 90% of the work done with the adaptives, right, and all these tool contours, these drillings, and you do your best, all I have to do is come back in and refine it. And you guys will be learning. And that way it's a good thing for us. Does that make sense?
Yep.
Cool. So I'll call it for today because it is almost 3:30. We've been here for about 2 hours now. And thank you for sticking around. I'm sure you were working on other stuff too, which is completely fine. You can absorb this. You can come back to it later. I'm going to make the recording public in a bit. So I'll see you guys later.
Yeah, thank you.
Yep. For saving, just be aware when you're done making edits to a file for CAM, all you got to do is save it and then go back into the PDM and check it back in, please, when you're done. So let me go to fluids, propellant tanks. No, it's going to be structures. Sorry. You guys get the gist, so you guys can head out whenever. I'll just leave this up here for people who are watching the video just in case. So if we go to propellant tanks, we go to BZB 10105 and we check in. Sorted. So it's checked in. We're good to go. I'll see you guys.